Maybe. Never assume.
Right, let's take a few moments and see how we're doing on these. If you're not quite done, that's okay. Let's see if we're on the right track. So I wanted to highlight the difference between evaluating and solving. Okay. Up to last Tuesday, all we had done was evaluate. That's when we have an expression. It doesn't equal anything, and we can't do much with this until we know what the variable is equal to. And so this is where we take that 3 now and we put it in for the x. And so we can rewrite this as 3 times 4 minus 5. Remember, when the 3 and the x are right next to each other, that means multiplication. And I put the parentheses around the 4 when I change that x to the 4. My goodness. This apparently is going to be just a day of errors for me. In case you ever thought teachers were perfect. In case you ever thought teachers were perfect, I have shown you multiple times already this morning. I am not. I'm going to put the 3 in for the x. Remember, when they're right next to each other, 3 and x, that's multiplication. I'm going to put a parentheses around the 3 that I substituted in because I wanted that to note as multiplication. If you just write 3 and then the 3 next to it, like the x's, it's going to look like 33 to you. But it's really 3 times 3. So we're taking 3 times 3 to get 9, and 9 minus 5 to get 4. And remember, we do multiplication before we do subtraction. That's our order of operations. Okay. I'll go through 1, 2, and 3, and then we'll see if you got any questions about those. Number 2, I'm going to put 6 in for x. So I'm going to put -2 times 6 plus 4. And again, I'm going to multiply before I add. -2 times 6, and negative times a positive, the signs are different. So that's going to be negative. 2 times 6 is 12. So I end up with -12 plus 4. And when I'm adding positives and negatives, if the signs are different, I subtract and I keep the sign of the larger value. So 12 is bigger than 4. So the negative comes through with the 8. Again, you can do those on your calculator as well. If you recall, for the GED test, you'll have the calculator for the majority of it. But a lot of the stuff that's on the beginning part, those first 5 problems, involve things like multiplying, dividing, adding, and subtracting positives and negatives. So it's a really good idea to be able to do them by hand. But you will have a calculator for the majority of the test. Okay, number 3, I messed up when I put x equals 4, because if x equals 4, but the expression has y in it, you can't substitute the 4 in for it. But I meant for it to be y equals 4. And so that's why I changed it when someone observed that here in page for me. And so I'm going to put that 4 in for the y. I'm going to have 3 minus 2 times 4. Remember that even though the subtraction comes before the multiplication, the order of operations say you do multiplication and division before you do addition and subtraction. So that's going to equal 3 minus 8. Because 2 times 4 is 8. 3 minus 8 is -5. You can reason through that. If I'm at 3 and then I take away 8, I'm going to be in the whole 5. Or remember that we can change subtraction to addition as long as we change the sign of that positive 8 to -8. These two, recall, are equivalent. They will give you the same answer. So you can think about these. You can think about this as 3 minus 8, or you can think about that as 3 plus -8. When we're adding and the signs are different, I subtract and I keep the sign of the larger value. And so no matter which way you think about it, the answer is that the expression is equal to -5. So we've got an answer of 4, an answer of -8, and an answer of -5. Questions about the first 3 problems? You can put them in the chat. You can turn on your mic. But if you've got some concerns or questions, make sure you get them answered. All right, so 4 through 9 involve what we worked on Tuesday. So if you were not here on Tuesday, this would be a great time to focus in, because you'll get a kind of a mini lesson on what we did on Tuesday. We started solving equations. Solving means we have an equation, which means we have an equal sign. And now nobody's going to tell us what X is. We have to figure out what X is on our own. Because this says if I add X and 4, I get 7. And so we're trying to figure out what number plus 4 is 7. Now you may be able to just look at that and know that 3 plus 4 is 7. And so X is 3, okay? But I also want to show you how you work it out so that when you get to problems that you can't do in your head, if I start throwing a lot of negatives in here, it's going to be more challenging for you to figure it out in your head. So we're going to start with a simple one that I hope you're convinced X is 3, because 3 plus 4 is 7. But I'm going to show you how we would do it algebraically so that as the problems get more challenging, you have a method. And we talked on Tuesday about opposite or inverse operations. And those are operations that undo each other. So subtraction undoes addition, or they are inverse operations or opposite operations. When we get down to here, division undoes multiplication. And so we're going to focus in on operations that will undo things that we want undone. We want to undo adding 4 to this X. And so the way we can undo it is we can subtract 4. We also talked about, if you've ever seen, like in science, like a 2-pan balance. And there's things on each the left and the right side. And if there's the same amount of weight on both sides, they're in balance. This is like having X plus 4 things over here and 7 things. So it's like having a little weight we don't know what it is, plus 4 paper clips is balanced with 7 paper clips. And we're trying to figure out, how much does this thing we don't know, how much does it weigh? And so I can take 4 paper clips off this left-hand side, as long as I do the same thing to the right-hand side. If I remove 4 paper clips and 4 paper clips, it will still stay in balance. So the key is opposite operation and do the same thing to both sides so that your balance stays in balance. 4 minus 4 is 0. And so all that's left is X on that left-hand side, and 7 minus 4 is 3. So that's algebraically how you would do the problem that you probably could figure out on your own, that 3 plus 4 is 7. Okay. So likewise, the opposite of addition is subtraction. So in number 5, we have subtraction, and the opposite of subtraction is addition. And so we want to get, I spent a lot of time highlighting things. Tuesday, we want to get this variable by itself. And so we're trying to remove anything that's with it. Minus 6 is with the X, so we do the opposite. We add 6. Minus 6 and plus 6 makes 0. X comes down, and 10 plus 6 is 16. We'll go do 4 through 6, and then I'll see if you've got any questions about any of those before we move to 7 to 9. So in number 6, I've got my X highlighted. There's 8 things with my X that have to go away if I'm going to know what X equals. The opposite of addition is subtraction. I'm going to do it to both sides. 8 minus 8 makes 0, so X comes down. And now I have negative 2 minus 8. And I didn't write that very well. If you counted that as a positive 2, I'll tell you what your answer would be, but officially it was a negative 2. Remember, when we're subtracting and we've got lots of negatives, it's harder to visualize how to do that problem. And so your best bet, if you're struggling with that, is change subtraction to addition and change the sign of the second number. If it's positive, it becomes negative. If it's negative, it becomes positive. Negative 2 plus negative 8. When we're adding, if the signs are the same, we add and keep the same sign. And so the answer would be -10. If you thought this was a +2 and you did -8, you would have gotten -6. So if you just misinterpreted the problem because I didn't write very clearly, then that would be your answer. Okay. So recall the other thing we talked about is you can check your work with these problems. We can put 3 back in for X just like we did on this left-hand side. And then when we put 3 back in here for X, we get 3 plus 4. And we want to know, is that equal to 7? It is. If you can confirm that, then that means your answer is correct. And so for number 5, I can plunk this 16 right in here for X. And we're trying to decide, is 16 minus 6, is that equal to 10? 16 minus 6 is 10. And yes, 10 does equal 10. So that means my answer is right. If I had plugged in my X and I'd come up with a statement like 9 equals 10, then I would know I've made a mistake somewhere. You should always get that this original equation works to a true statement. And then in number 6, I can put in that -10. We're asking, is -10 plus 8, is that equal to -2? -10 plus 8, signs are different. So I subtract, I keep the sign of the larger. And yes, -2 is equal to -2. So that means my answer of -10 is correct. All right, so 4, 5, and 6. That was like pages 34 and 35 out of your packet from Tuesday. Are there questions about any of those 3? Then you can jot me a question in the chat. You can turn on your mic. All right. So 7, 8, and 9 are different in that instead of adding and subtracting things, we are multiplying something by the variable in 7 and 8. And in 9, we're dividing the variable by a number. And so we are going to do, again, opposite or inverse operations that will undo each other. In number 7, I want X again by itself. And that means the 3 has got to go away. Okay. 3 is being multiplied by X. And so if I want to get rid of the 3, I'm going to divide by 3. Whatever I do on the left, I do on the right. The reason this works is 3 divided by 3 is 1. And so I'm left with 1x, and 1x is the same as just x. You can write it either way. If I say I have an apple in my lunch, you know I have 1 apple, even though I didn't tell you I had 1. And so x is the same as 1x. Question? Anyone have a question? Okay. Brian, I can tell your mic is on, but I can't understand, I can't hear you. So if you've got a question, if Daniel's not there to help you with the question, can you write it to me in the chat?
Yeah.
Okay.
No.
And then on the right-hand side, 12 divided by 3 is 4. So my original equation was 3x equals 12. I can put that 4 in for that x now to see if it's a good value. And 3 times 4 is 12. And so that means my x equals 4 is correct. Or Ryan, it looks like Daniel just walked in. If you've got a question, you can tell him and then he can speak it in the mic for me.
We're good at the moment.
Okay, great. All right, so number 8, again, I have multiplication. I have -4 times x. And so I'm going to get rid of multiplication by dividing. And I want to divide by -4. And the reason is a negative divided by a negative is a positive because the signs are the same. -4 divided by -4 is 1, which leaves me with 1x or just x. Again, that's the same. And so x is equal to whatever 20 divided by -4 is. Signs are different. The answer is negative, and 20 divided by 4 is 5. Again, I can check my work. I can put in the -5. I'm trying to answer the question, is that equal to each other? And -4 times -5, when the signs are the same and I'm multiplying, the answer is positive. And so that checks out that it is a correct value. And then number 9, the variable is being divided by 7. And the opposite of dividing by 7 is multiplying by 7. Whatever I do to the left, I do to the right. Okay. I still have 7 divided by 7, which makes 1. And so I'm left with x equals 5 times 7, which is 35. And so if I want to check my work, the original problem was this. I plug in the 35 where the x is, and I'm asking the question, is 35 divided by 7 equal to 5? 35 divided by 7 is 5, and so they are equal. And that means my original answer should be correct, barring any other, just mistakes that I've made that cancel each other out. But you can know pretty confidently if you can plug in your value and make a true statement that this answer should be correct. Okay. So thoughts on or questions on 7 through 9, or on anything actually 1 through 9 that we've just taken a look at. 4 through 9 are a recap for what we did on Tuesday. All right, let's take a look at number 8 on page 35. Remember that we leave problems undone for you to do on your own to get some practice. So it's a really good idea to practice math. Math is not a spectator sport. And if you want to get better at shooting free throws, you shoot free throws. And if you want to get better at math, you got to do some math. Okay. Math can always look way easier when someone else is doing it. So let's take a look at number 8. Says Nita earns $580 per week. The total of her and her husband Craig's weekly salaries is $1,124. Let C equal Craig's weekly earnings. How much does Craig earn per week? So we know that Nita earns this much. And we know that the total is $1,124. Anybody know what operation total usually means? So we're totaling something up. Usually what operation are we doing? I heard something, but I didn't hear it clearly enough. Sorry. If I'm going to total up all the donations someone gave to the to the animal shelter, I'm going to total up how much I spent on coffee last week. What am I doing to those numbers? What'd you say, Brad? No, we're not subtracting. We are adding. I'm going to total up how much I spent on coffee last week. I'm going to add up how much I spent each day, add them up for a total. So when it says the total of her and her husband Craig's weekly salary, that means when we add her salary plus his salary, we equal that much. So if I add her salary plus his salary, I'm going to get $1,124. We don't know how much his salary is, but it suggests that we use the letter C to represent it. And so her salary plus his salary is $11.24. And so that's turning a real life situation into an algebra problem. We are adding those two things. And so to get rid of that 580 to find out how much he makes, we want to subtract off. We want to get rid of the 5. We want to get rid of this so that we have C equals some number. The way to get rid of it is to subtract it because that makes 0. And all that's left now on the left-hand side is C. And it says that C should be equal to whatever 1124 minus 580 is, which my calculator says is $544. Okay. So again, this is a pitch for, I would really encourage you to go back and work through some of these that we've left undone to make sure that you can do them. Particularly word problems, nobody likes them, but the only way you get better at them is to do them. That's just the sad fact of the matter. Okay. Any questions about number 8? Again, if I put this back up here, if I add 580 plus 544, I should get 1124. Okay, 580 plus 544 is 1124. So I have successfully found out what his earnings are per week. All right, if there's no questions, we're going to take a look at page 37. So any last final questions about number 8? All right, so page 37 is an extension of this multiplication and division lesson. And this example says using reciprocals, and we talked Tuesday about what a reciprocal was. We did it in the warm-up, and we talked about if I have the fraction 2/3 and I multiply that by the fraction 3/2, these are reciprocals because a reciprocal simply means I take a fraction and I flip it upside down. What was on top becomes on bottom. What was on bottom becomes on top. So these two fractions, 2/3 and 3/2, are reciprocals. Okay. And the neat thing about a reciprocal in math is when you multiply reciprocals, we did a little fraction lesson Tuesday. To multiply fractions, one way is to multiply across the top, multiply across the bottom, and you get 6/6, which equals 1. We also talked about the other way to multiply fractions is since there's a 2 on the top and a 2 on the bottom, we can say 2 divided by 2 is 1, or that we cancel these out. May have been language you're familiar with from school. And we can cancel out or divide 3 divided by 3 and be left with 1. And that's another way to show that this answer 2/3 times 3/2 is 1. Okay, so all reciprocal pairs, if you multiply them, will always equal 1. And we're going to use that then to be able to solve an equation that has a fraction being multiplied times the variable. Now I know nobody likes fractions, but we do have to know how to work with them. Okay. So this is saying 3/5 times A equals 30. So the fraction 3/5 times some number is 30. And this is where it's a clear example of you probably can't figure out what that number is off the top of your head. Even better is if your answer, sometimes you'll have problems where the answer is a fraction. And so you're not going to be able to do most of those in your head. And that's why we need a method for how to do these. And so what I'm going to do is I want to get rid of that fraction. And so if I multiply this fraction by its reciprocal, I'm going to get 15/15, which equals 1. Okay, so that's 1A, which is the same as A. Whatever I do to the left-hand side of an equation, I have to do to the right-hand side of the equation. So I'm going to multiply the right side by 5/3. And so these cancel and give me 1a on the left. And so now I have to figure out what 30 times 5/3 is. You can use your calculator. Or again, it's a good idea to know how to operate with fractions. So we're going to do this one by hand too, but you can put it in the calculator. Remember, if I have a whole number 30, I can put that over 1. So really, I'm multiplying 30 over 1 times 5/3. One way to do it is multiply across the top, multiply across the bottom, and the answer is 150 divided by 3. You'll never see that as the final answer because 150 divides, 3 divides into 150. 150 divided by 3 is 50. Okay, so that's one way. Multiply across all fractions. If you're multiplying, you multiply across the top, multiply across the bottom, then you've got to reduce or divide that out. The other way you could get to that answer is 30 is divisible by 3. And 3 is divisible by 3. So I can do 30 divided by 3 to get 10, and 3 divided by 3 to get 1. And so then what I'm left with is a 10 times 5 on the top, which is 50, and 1 times 1, which is 1, and 50 divided by 1 is 50. Okay. The first method, if you multiply across the top, multiply across the bottom, you will usually get, well, you're going to get larger numbers and you're going to likely going to have to reduce or divide it out. If you're able to divide out these common factors, 3 is a factor of 3 and 3 divides into 30 to make 10, then your final answer typically won't have to be reduced at all. If you get all the common factors divided out, then this final answer won't have to be, will be in simplest form when it's done. Either way works. Final way is if I want to take 30 times the fraction, remember the fraction key on our GED calculator is 3 above the 7, and I'm going to multiply it times 5/3. And it will also tell me that it's 50. Okay. So step 1 is you've got a fraction being multiplied times your variable. Okay. You flip the fraction over to get the reciprocal. And you multiply that reciprocal times the number that's in front of the variable, and you do the same thing to both sides. And that reciprocal knocks out the fraction, gives you just your variable, and then you have to simplify the other side to get 50. Okay. Again, I can put 50 back into here, and this says that 3/5 times 50, we want to see, is that really 30? Okay. We can multiply across the top and the bottom and get 150 divided by 5. And 150 divided by 5 is 30. So that checks out. Or you can say 5 divides into 5 and leaves 1. And 50 divided by 5 leaves 10. And 3 times 10 is 30. Or you can use your calculator to check it. Okay. So fraction work and reciprocals go hand in hand. The nice thing is when you're doing your reciprocal on this side, you don't really even have to, as long as you have the reciprocal, you don't have to multiply those out. It should get you to your variable. And then you only have to multiply that reciprocal times the other side. So let's take a look at number 5 or 6, I guess it is here. We have 2/3 times n equals 12. And so if the fraction being multiplied times the variable is 2/3, what's the reciprocal? I flip that fraction over, what number's on top?
2.
I can just barely hear you.
3.
Okay, I've got from Paige, I got that 3's on top. 3's goes from the bottom to the top. And so the reciprocal is, instead of 2/3, it's 3/2. So I'm going to multiply that times 2/3. And I'm going to take 12 and multiply it times 2/3. These cancel each other out and leave me 1. And so what n is equal to whatever 12 times 2/3 is. One way to do it is multiply across the top. 12 times 2 is 24. There's a 3 on the bottom, and 24 divided by 3 is 8. The other way to get it is 3 divides into 12. So 3 divided by 3 makes a 1 on the bottom, and 12 divided by 3 makes a 4 on top, and 4 times 2 is also 8. And so n equals 8. So that means that 2/3 times 8 should equal 12. And so we can take that in our calculator if we want to. Fraction 2/3 times 8. Whoops. You know what? You guys didn't catch my mistake. I was thinking that's not going to work out. Let me show you why I know that this wasn't right. It is definitely my day for mistakes. 2/3 times 8 is not going to be 12. Curtis, why didn't you point it out? So I checked my work and oh my gosh, it doesn't equal 12. And I could see that as I started to stumble in my head because I was like, 2/3 times 8 is not going to be 12. Can anyone see what I did wrong? So that means this equals 5.3, which does not equal 12. So now we go, we've made a mistake. Can anyone see my mistake? I multiplied the left side of the fraction by what? 3/2, and I multiplied the right side of the fraction by a different number, didn't I? I multiplied the left-hand side of the fraction by 3/2, and I multiplied the right side of the fraction by 2/3. And nobody said, hey, you can't do that. Okay, so here's my mistake. Okay, those are different numbers. I can't do that. I got to keep my pan balance in balance. I have to multiply by the same thing. So this is why it's never a good idea to do math in pen. So if you wrote down that in pencil, you just erase it. And if you wrote it in pen, we're just going to start over. Okay. 2/3 n equals 12. Okay, so I did right. I multiplied by the reciprocal on the left. I need to do the same thing on the right. For those of you who sometimes have trouble mixing up numbers, I just did exactly that. You're not alone. All right, so now these cancel out and make 1. So I did the left-hand side correct. I just wrote the wrong number for the right-hand side. So let's try this again. 12 times 3 is 36. And I have 2 on the bottom. And 36 divided by 2 is 18. Thank you. I've got people on page cheering me on now. I did it right. Okay, so the other way to deal with this fraction, you can multiply across the top, multiply across the bottom, divide. Other way to do it is to say 2 will divide into 12. So 2 divided by 2 makes 1, and 12 divided by 2 makes 6, and 6 times 3 gets me straight to the 18. Okay, so now let's check our work. Because I don't think I'm going to have that sinking feeling I had just a moment ago when I wrote down 2/3 times 8. 2/3 times 18 is in fact 12. And that means that was a way that I would know that this answer was correct. Okay, so you got to see a real life occasion where I went to check my work and I went, oh dang, those are not equal. Something's wrong with this answer. And then I figured out what I did wrong. I corrected it. I got a new answer. I checked it. And this time it came out 12 equals 12, which is true. Okay. You got 18, Curtis? Very nice. So do make sure if you see me make a mistake. I love it when students find my mistakes because it helps me. And also it means that you're watching, you're looking, you're trying to do it yourself, and you're catching when I mess up. So, all right, so let's try this third one over here. Remember this darn resource I take it from. These all three are problem 6, but I want to deal with this one because it has some negatives in it. And then I'm going to give you a few moments to try some on your own. Okay, so I have the fraction -4/9 being multiplied times b. And so I need to get rid of that fraction. And so I'm going to multiply by what? You put it in the chat. You can holler it out in flag. You can turn on your mic. What should I multiply by? Be brave. I want to make it 1. Ryan, I couldn't quite hear you through the mic. What fraction can I multiply by 4/9 to get 1? Or in other words, what's the reciprocal of 4/9?
9/4.
Yeah, here in page, we got 9/4. Now the question is, this one is negative. So should I multiply by a positive 9/4 or a negative 9/4?
Positive.
If I multiply by positive, a positive times a negative is a negative. And I want to just have b. If I multiply by a negative times a negative is a positive. Because if the signs are the same, when we're multiplying, that's how we get a positive. So I do want to multiply by a negative 9/4. And let me write it real quick before I'm gonna write it on the other side so that I make sure I've got the same. Okay. That's the mistake I made last time. I wrote the fraction and then I didn't write the same fraction over here. So a negative times a negative, signs are the same. That will give me a positive. So I don't have to worry about the sign. It's positive. And 9/4 times 4/9, these cancel and leave me 1. So I have 1b or just b. I don't like it when they use b because b's look like 6s. So I'm going to change it to a capital B. So b equals whatever 16 times -9/4 is. Okay. I can do 16 times 9 and get a big number and then have a 4 on the bottom. Okay. 16 times 9 is getting a little more challenging to multiply though. So if I can reduce these numbers a bit, I won't have such big numbers to multiply. So I could notice that 4 divides into 16. So 4 divided by 4 leaves me 1, and 16 divided by 4 leaves me 4. And I'm going to go ahead and put a negative up there because the 16 was negative, so the 4 is still negative. Now all I have to multiply by is -4 times -9. A negative and a negative, when I'm multiplying, the signs are the same, so it's positive, and 9 times 4 is 36. Okay, so if I want to check my work, the original problem, before I marked it all up, said -4/9 times whatever I get for B should equal -16. So we want to ask the question, does -4/9 times 36 equal -16? So I'm just gonna plug it in the calculator. I do a fraction, -4 on top, 9 on the bottom, times 36 equals -16. And so this is true. And that means that my answer of B equals 36 is correct. Okay, what I would like for you to do, I'm going to back out my zooming here, is I want you to try. I'm just going to give you about 5 minutes to work, and you do any of these that you can in the time. And then we'll go over several of them. Remember, the answers are in the back. You can also reach out to me through the chat. Let's see what you can do on these up here in the time that you're given. You may not have time to finish, and that's okay, because you do have the answers and you can check your work later if you need to.
What are we doing? Sorry.
The ones that are left up here. Whatever you can get done.
Oh.
Ease reflection, push
Yeah.
button to hear you for your reflection.
Gotta know what A is. You can't put A in there. So you multiply, so you want to multiply this side. That's 3.
Five.
You could say 3 divides into 45.
Seven, 15.
3 divided by 3 is 1. Did you check out? Okay, let's take a moment and talk about these. If you didn't finish these 4, that's totally fine. If you've already finished them and moved on, that's fine too, but let's take a minute and go back and make sure you're on the right track. And if you weren't, then we'll get you corrected before you do too many problems. This first one here, 2/5 times y is 10. We want to multiply this times the reciprocal. And thanks, Rod. And so I cancel out on the left-hand side, and that leaves me just 1y or y. And then I have to multiply 10 times 5 over 2. You can multiply across the top and get 50, and 2 on the bottom, and 50 divided by 2 is 25. Or you can say 2 divides into 10, so 2 divided by 2 is 1, and 10 divided by 2 is 5. And then you have 5 times 5, which is also 25. So for this middle problem on the number 6 line, the answer should be y is 25. And you can check that. Put in your calculator 2/5 times 25. And we want to see, does that really equal 10? And so I can use my calculator. I can make a fraction, 2 on top, 5 on bottom, times 25. And it does in fact equal 10. And that's how I know that my answer of 25 is correct. Any questions on that one? Okay, let's do a couple more. So number 7, 3 over 7 times a is negative 45. I flip the fraction. I do it by both sides. So I got those cancel and leave me 1a. And now I have to take 45 times 7, negative 45 times 7 over 3. I can multiply across the top and multiply across the bottom. 45 times 7 is not something I want to do in my head. So, but you can, or you can say 3 divides into 3 1 time, and 3 divides into 45 15 times, and it's negative. And so that negative 45 becomes a negative 15, and now I just have to multiply negative 15 times 7 instead of 45. So I got negative 105. So I want to check it. 3 over 7 times negative 105. Does that really equal negative 45? So I make a fraction, 3 on the top and 7 on the bottom, times negative 105. And it does in fact equal negative 45. Okay. So again, these take practice, okay? And I would encourage you to take some time, even if you just spend 5 or 10 minutes every day or two and do a couple problems and check your answers. If you feel like you finish all these and you still don't feel like you are competent in them, there's a couple things you can ask me for more problems for you to do, which I can provide, or you can simply take the original problems, rewrite them on a fresh sheet of paper and see if you can do them again and get the right answers. These are probably the most challenging just because most people have kind of a fraction aversion. And so for most students, these are the most challenging. But equipped with your calculator and equipped with that idea that we can reduce fractions before we even start multiplying, they don't have to be hard. So I want us to take a look at one more thing before this class is over. So there's a few more problems on here for you to try. Answers are in the back of the packet, and if you get stuck on some, then you should ask me in class next week. Let's take a look at page 38. Because so far we've been looking at problems that we either add to get or subtract to get rid of the thing that's with the variable, or we multiply or divide. And now we're going to put those together, meaning we're going to have an equation where the variable x, in this case, has a 3 multiplied by it, and it has a 5 added to it. And so this is a picture of that pan balance I was trying to draw earlier. That idea, this says 3 times x, or 3 x's plus 5 is equal to 26. And the idea is now we have to undo the 3 and we have to undo the 5 to figure out what the x is. And so the question is, what do we do first? Do we try to get rid of the 5 first, or do we try to get rid of the 3 first? Anybody know? Okay, I have a suggestion of getting rid of the 3 first.
The 5?
I have a suggestion of getting rid of the 5 first.
5 first.
Okay, I've got a couple votes for 5. The answer is that's actually a trick question because you can do either. However, it comes with a huge however. If I get rid of the 3 first, I have to divide everything by 3, which is going to make fraction, and then I'm going to have to start adding and subtracting fractions. Nobody likes to do that, right? So the answer to my question was, it really doesn't matter. You can get rid of the 3 first or the 5 first, but if you don't want to have to deal with a bunch of fractions, you should always divide last. Okay? Because if I get rid of the 5 first, then I'm only going to have the 3x and some number, and that's the only thing I'm going to have to divide by 3. If I divide by 3 now, I divide this by 3, 5 by 3, get a fraction, 26 by 3, get a fraction. Nobody likes fractions.
Yeah, x is unknown, so we don't know.
Right, the x is unknown. And the x in the end might be a fraction, but if we divide last, we'll create the fraction just at the very last step, and we won't have to do a lot with it. Okay, so either is correct. Easier, always easier is to get rid of this 5 first. Okay, so this 5 is being added to the 3x. So to get rid of adding 5, we subtract 5. I think I heard that maybe from Flag. Okay, so just like the first day, we're doing the opposite of adding, we're subtracting. But now what comes down is not just x, we still have 3x left. So the 3x comes down, 26 minus 5 is 21. And now we have an equation that looks just like Tuesday. 3 times a number is 21. The opposite of multiplying is dividing. 3 divided by 3 is 1, or 1x. And 21 divided by 3 is 7. Okay, and that's what they're showing you in this diagram. The first thing they did to go from this picture number 1 to picture number 2 is they took off the 5 and they took off 5. And then they to go from picture number 2 to picture number 3, they divided by 3 and they divided by 3. And so these, if we do the same thing to both sides every time, our balance stays in balance. Okay, we can still check this. Okay, this 7 can go all the way back up here. 3 times 7 is 21, plus 5 is 26. And so that tells me that my answer is correct. And 3 times 7, I have 21 plus 5, or 26 equals 26. Okay. So we're doing 2 inverse operations this time. Okay. And my hint to you is it's always easier. It's almost like the reverse of the order of operations is it's always easier to get rid of the plus or minus first and then deal with the multiplication or division. And we're doing the same thing to both sides. So we're not violating the order of operations because the order of operations is the order you do a series of operations all in one expression. Okay. So this problem here says 9 equals x over 4 plus 7. So I'm looking for the x, but I'm going to deal with this adding 7 before I worry about the dividing by 4. Okay. So I'm not going to add 7 because the opposite of adding 7 is subtracting 7. And so this is gone. And so I have x over 4 and 9 minus 7 is 2. Now I have x is being divided by 4. The opposite of dividing by 4 is multiplying by 4. 4 divided by 4 makes 1. And 4 times 2 is 8. Okay. So the big strategy is get rid of your addition and subtraction first and then worry about multiplication and division. If you do that, then if there's no fractions to start with, you won't get fractions till the very last step if the answer is a fraction. And you'll have to operate, add and subtract and multiply and divide less with fractions if you do that first. Okay, so let's take a look then at page 39. And I'm gonna, since I write so big, I'm gonna write these on another sheet of paper. Okay, so I don't want to divide by 3 because I'm going to get 2/3 and I'm going to get 62 over 3. You can actually get the right answer if you do that, as long as you operate with all your fractions correctly, but your likelihood of error increases incredibly if you do that, if you create those fractions. So I want to focus in. I'm trying to get m by itself. I've got to remove the 2. I've got to remove the 3, but let's work on the 2 first. Opposite of adding 2 is subtracting 2. That makes 0. 3m, we haven't done anything with yet, so it's got to come down. And 62 minus 2 is 60. See, these two are connected by multiplication. Opposite of multiplication is division. 3 divided by 3 makes 1. And 60 divided by 3 is 20. And remember, I can put it all the way back up here and say, is 3 times 20 plus 2, is that really equal to 62? 3 times 20 is 60. And 60 plus 2 is 62. And since I got a true statement here, that means that m equals 20 should be a good answer. Remember, that's how I knew I'd made the mistake on that other problem because I came up with 5.3 equals 12, which is not true. And then I could go back to this and say, I've made a mistake. This answer is not right. And then we went back to find our error. Okay. All right, so that means that for number 1, M is 20. Okay, I'm going to give you some time. Let's have you work on, let's just go down this column and have you work on these for about the next 7 minutes. You may not finish, and that's okay, but see what you can get done on these that are highlighted. And then we'll go over them before class ends and make sure you're on the right track. You can always reach out to me via the chat if you have a question. I would probably recommend you write on another sheet of paper because there really isn't enough room for you to get all the steps in. And if you squish up your work really tiny, that's when you tend to make errors. Okay. You may not have finished all the remainder of those, and that's okay. Let's go over what we can before the class is over, and that way we'll make sure you're on the right track, or if you're not, maybe we can do a course correction so that hopefully when you practice on your own, you'll be ready to go. So number 2, all I've done is rewrite it. Okay, we're looking for X. We need to get rid of the 4 and the -7, but we're going to attack the -7 first. The opposite of subtracting 7 is adding 7. 4x comes down. And now we have -83 plus 7. You're welcome to use your calculator to find that answer. -76, thank you. Okay, signs are different, so we would subtract and take the sign of the larger. So 83 is bigger than 7. Now the next thing we need to do is we need to divide by 4 because this is multiplying by 4, and 4 divided by 4 is 1, leaving me just my x. And then I want to take 76 divided by 4, negative what? -19, very nice. Because 76 divided by 4 is 19, the signs are different. When we are dividing or multiplying and the signs are different, the answer is always negative. And again, we could go back. We could say 4 times -19 minus 7. Is that equal to -83? And this one, I'm just going to plug it in the calculator. 4 times -19 minus 7 is in fact -83. That's true. So that means that answer should be a good answer. So x equals -19 should be our answer for number 2. Thoughts or questions? If we look at number 3, we have 8x plus 1 equals -55. Remember when I said at the beginning, we started out with that easy problem like x plus 4 is 7, and I said you might be able to just see that the answer was 3. You can start to see now why trying to figure out what x is off the top of your head is going to be pretty challenging. Okay, that's why we need a method. And so we want to solve for x, but we want to focus on this +1 first. And so the opposite of +1 is -1. Whatever I do to one side, I do to the other. That makes 0. 8x comes down. -55 minus 1 is -56. And if you have a hard time visualizing, again, that subtraction, remember we can change that to adding a -1. When I'm adding 2 negatives, I just get more negatives. So he's right, it's -56. And now 8 times x, the opposite of multiplying, is dividing. That helps me because 8 divided by 8 is 1. So I have x equals -56 divided by 8. 56 divided by 8 is 7, and the signs are different, so the answer is negative. Again, I can come back here. I want to verify that 8 times -7 plus 1, is it really -55? And I can put that 8 times -7 plus 1 in the calculator, and it is -55. So that's true, which means that's a good answer. Okay. Questions?
Yeah, I did everything right except the negative and positives.
Okay.
That's where it
And you
really-
can use till you get used to the the rules. You can also use your calculator to help you. The important thing is, even if you didn't get the answer -7, let's say you divided wrong or you did the wrong sign. Right now, I'm probably more interested in, are you getting the right procedure? Are you knowing to subtract 1? And are you knowing to divide by 8? If you've got some computation errors in here, we can clean those up, okay, as we get more practice with positives and negatives, and we can also use the calculator to help us. But most important is, are you getting the process right? And if you're getting the process right, some of the other stuff will start to fall into place as we go. Okay, let's do one more and then that was number 3. Let's do, huh? Okay, you need help with it. Well, we're gonna do that one. We'll have time for that. I'm gonna change this to a capital B because my lowercase b's look like 6s. B over 2 minus 4 equals -7. Okay, so B is my variable. I want to deal with -4 first. Opposite of subtracting 4 is adding 4 or +4. So B over 2 comes down. -7 plus 4, signs are different. So I subtract, keep the sign of the 7 because 7 is bigger than 4. So now now my B looks like an 8. I have B over 2 equals -3. So that's B divided by 2. The opposite of dividing by 2 is multiplying by 2. 2 divided by 2 is 1. And so I'm left with B equals -3 times 2. Signs are different. So my answer is going to be negative, and 3 times 2 is 6. Again, I can come back up here. Is -6 divided by 2 minus 4 really equal to -7? -6 divided by 2 is -3 because the signs are different, so the answer is negative. And -3 minus 4, you may know that that's -7, or you can change subtraction to addition. Change the 4 to a negative. -3 plus -4 just makes more negatives. It makes 7 negatives. And so that's true. And so that means that this answer should be good answer. Okay. All right, I'll leave you with the same thing. You're gonna just want me to stop saying it, I'm sure, but practice, practice, practice is the way you'll get better at these. Answers are in the back, so you can check your work. I think on all of these, they even show you the steps of how to do it. But if you get stuck, or if you're like, I'm just really needing some more assistance on this, then you can, if you get on Canvas, you can make a coaching appointment. You can reach out to me by email or remind or phone, and we can schedule some time together, just the two of us, to work. But this is a really critical, these algebra skills are critical skills for the GED. So we really, really, really want you to get these because it's really going to help you with passing the math GED. Okay, that's all I have for today. We're about 1 minute over. I apologize for that. And I hope to see you next week. I'll stay on for a few minutes if anybody wants to ask some questions or talk to me.